Tonight our homework notes are going to be on sectors of circles. So the word we're focusing on is sector, and we're going to talk about what a sector is. All right, so first I'm going to draw what it looks like in a circle so that the definition will make a little bit more sense. So a sector is when we have a slice kind of cut out of the circle like that, where we've got a degree and a radius, and the sector it's like shaded in our pictures usually. It's representing that part of the circle. It's kind of like a pizza slice, right? So technically it's a section of the circle and it's not just any section of the circle. It's not just like a chunk cut out of it by any chord specifically. It's a section of the circle bound by a central angle. So it's coming from that center point here, okay? It's bound by a central angle and its intercepted arc. So that intercepted arc is this arc here. Kind of like if we're thinking about this sector is pizza slice, this is like the crust of the pizza slice. Okay. All right, so it's bound by the central angle and its intercepted arc. Listen, I'll be talking about pizza a lot. Sometimes teachers talk about pie slices, but I like pizza way more. So, so a sector is like a slice of the pizza. Awesome. So there is a formula that we use to find the area of a sector. So how do I find the area of a sector? Area of a sector. Okay. We find it by this formula. Okay. So think about the formula for the area of a circle, right? Well, the area of a circle is pi r squared. So a sector is just a portion of that circle. And that portion is determined by the degree of the central angle. So it's the area of a circle, pi r squared, times the degree of the central angle, divided by the entire angle measure of a circle, which is 360. So think about what this area of a sector formula looks like. It's similar to a formula we've seen before. It's kind of similar to arc length. Remember, arc length before looked like the area of, the measure of the angle times the circumference divided by 360. So it's very similar to finding the area of a sector. And this is also why they don't give us these formulas on our formula sheet, because a lot of it just comes from what we know about the area of a circle or circumference of a circle, multiplying that by the angle that we're looking for and dividing it by the total measure of the circle, total angle measure. Okay, so just to be clear, x represents the degree measure of the arc. So the degree measure of the intercepted arc, and r is just talking about the radius of the circle. So it's very similar to arc length, except now we're finding area. So let's go ahead and do some examples. So for the first one, for all of these, we're going to find the area of the shaded sector. All right, so let's have our circle, and let's go ahead and draw a sector. And I'm going to say that this is point B, this is A, this is C. This goes all the way to the edge of the circle. And let's say that this angle measure here is 51 degrees. And the shaded area is this little pizza slice. Okay. I want to find the area of the shaded section. Okay. A couple things we need to know here. We know that the measure of the shaded section, the measure of that arc, AC, is 51 degrees. But one thing we also need to know is the radius. So I'm going to tell you that BC, the radius, is 16. Okay. And I'll give you a unit. Let's say it's 16 feet. So we're going to use the formula that we just wrote. So the measure of the arc times pi r squared, or the area of the circle, divided by 360 will give us the area of our sector. So the measure of our arc, or AC, is 51, because that's the central angle, times pi r squared, or 16 squared, divided by 360. Okay. So put all that in your calculator, and let's round to the nearest hundredth. And we should get that our answer is approximately 113, oopsies, a lot of typos today, 113.94 feet squared, or square feet. So this sector, the area of this sector is 113.94 feet squared. Awesome. All right, let's try another one. So for this one, let's say that I tell you X, Y, and Z, and then I'm going to tell you that the measure of angle, the measure of angle XYZ, I'm going to say that angle is 42 degrees. This time I want you to find the measure of this sector. Okay. So there's a couple things you could do. You could find the measure of this sector, the XYZ, the smaller sector, and then subtract that number from 360. Or you could find the measure of this entire sector here. Let's say we want to find the measure of this shaded sector directly. So we need to know the degree of the measure of the arc. So we need to know the degree of this arc, X all the way over to Z. Okay. And we need to know the area of the circle. So pi r squared. And we'll divide that by 360. Well, if the entire circle measures 360, this much is 42. That means that this entire angle must be 318 degrees. Okay, so that's going to be important. That's our 318. So now we need to know what the radius is. I'm going to tell you that the radius is 9. Let's say it's inches. So pi times 9 squared divided by 360. All right, let's go ahead and figure that out. We'll round it to the nearest hundredth. We should get that the area of this sector is approximately 224.78 inches squared, or square inches. Awesome. So again, if you wanted to do it the other way, you could totally use this 42 times pi times 9 squared over 360, because that would give you this sector, give you the area of this sector. All right. If you wanted to find it this way, you would find that the area of this sector is 29.67 approximately inches squared, and then you'd subtract that, so take away from the area of the circle. Okay, so you take it away from the area of the entire circle. So you'd find the area of the entire circle, subtract this number, and get approximately this number. Okay, it might be slightly different whether you're using the pi button or using 3.14. All right, so the last example I want to show you is we've so far just been looking at one sector from the circle, but what if you needed to find the area of multiple sectors of the circle? So for instance, you might have, let's say we have a diameter. Okay, so let's say that's M, N, J, and then let's call this LK. We're going to say that LK is 58 degrees. And then I'm telling you that MNJ is a diameter. Okay, and we're going to shade in these two sections. There's that, and then this entire section here. So if the goal is still to find the area of the shaded sections, we're finding the area of more than just this 58 degrees and more than just half the circle. Right? So you could do this a couple different ways, but just one way to do it is if this is 58 and this entire angle measure is 180, just add those numbers together. So take your 180, add it to 58, and you're going to get 238. You can treat 238 as the entire measure for the sector. So you can still use that same sector formula. Instead of finding the area of this sector, the area of this sector, and adding, you can just do it in one step. So we can say 238 times pi r squared, and I'll tell you that r is 5, so pi r squared over 360. Okay. So you can go ahead and try that. And we should get approximately the area of the entire shaded region, both this half and that little pizza slice, is going to be 51.92. Let's say it's meters squared, or square meters. All right. Okay, make sure you do the questions that are posted. There should only be a few. Use your notes. Make sure you're plugging in correctly to that formula, and I'll see you next class.